Today we're going to be talking about the graphs of the sine and cosine functions. A function f is a periodic function if for every real number x in the domain of f and for some positive real number p, f of x is equal to f of x plus p. The smallest positive value of p is called the period of the function. If f has a period p, then the graph of f on any interval of length p is called one complete period of f. It turns out the functions sine and cosines have periods 2 pi. This means the sine and cosine functions are periodic. And the reason that is because if you take an angle theta and you take sine of theta plus 2 pi, that is going to be equal to sine of theta. And let's think about why that is. If we think about the unit circle, let's say we have some angle theta here, and it has terminal point. The coordinates would be cosine of theta, sine of theta. And if I added 2 pi to theta, that would end me right back here with the same coordinates because theta and theta plus 2 pi are coterminal angles. Same thing with cosine. It is a periodic function because if I add 2 pi, if I take cosine of that angle theta and cosine of theta plus 2 pi, they will give me the same values. Consider a unit circle and look at how the sine and cosine functions change. Keep in mind that a point on the unit circle has coordinates cosine theta, sine of theta. So if I am in quadrant 1, the starting angle for quadrant 1 is 0, and we go to here, which is pi over 2. So we go from 0 to pi over 2. For quadrant 2, we start at pi over 2, and we go and stop here, which ends us up at pi. For quadrant 3, we start at pi, and we go down here to 3 pi over 2. And then for quadrant 4, we start at 3 pi over 2 and then go to 2 pi. Now let's go back to quadrant 1, and when we are at an angle of 0, we know the coordinates here are 1, 0, and then at pi over 2, those coordinates are 0, 1. So if we're thinking about sine of theta, as the angle gets larger and closer to pi over 2, then that means that the sine value is starting off at 0 and going towards 1. Okay, what about the cosine value? Well, cosine is starting off at 1, and then as we get closer to pi over 2, it's going towards 0. All right, let's go to quadrant 2 now. And we're starting off at pi over 2. And so the sine value is starting at 1 and then going back to 0, since we are starting at the top and then coming and ending up right here. And at pi, the terminal point is -1, 0. And so we know that the sine value is starting at 1 and then going towards 0. What about cosine of theta, though? So the x value here is 0, and then as we get closer to pi, it's going towards this value, which is -1. All right. Now, let's look at quadrant 3. For 3 pi over 2, that terminal point is 0, -1. And for the y values, we are starting with 0 and then going towards a y value of -1. And the x value is starting at -1 and going towards 0 here. And let's lastly talk about quadrant 4. If we go all the way to 2 pi, that ends us back at 1, 0. And so the sine value is starting off at -1 and then going back to 0, and the cosine value starting at 0 here and then going towards 1. So what are the domain and range for these two functions? Now notice if I do one revolution, I'm starting here at 0 radians and I'm going around and I do a full rotation and that ends me up at 2 pi radians. But I can keep going past 2 pi. I could do another full rotation, go to 4 pi, 6 pi, 8 pi, and keep doing full rotations and finding the sine and cosine values of that angle. I can also go in the opposite direction. I could start at 0 and then go clockwise and end up here at -2 pi, and I can keep going in the clockwise direction and go to -4 pi, -6 pi, and etc. So it turns out that the domain for both the cosine and sine functions are -infinity to +infinity. However, the range is not going to be -infinity to +infinity, because the unit circle has a radius of 1, and so the maximum and the minimum value that our output values can be for sine and cosine is, let's just think about the y value, which is associated with sine. So here's my unit circle. If I'm starting here at 0 and I'm going around, the highest value, or the maximum possible value for sine, is going to be at this point here, 0, 1, and the highest value would be 1 for sine. And the lowest value for sine, if we keep going around the circle, if we're thinking about the y value, the lowest y value occurs at 3 pi over 2, at the terminal point 0, -1. So -1 is the smallest range or output value. And we just illustrated that for sine, but the same thing happens with cosine. The smallest cosine value is going to happen here when the x value is -1, and then the largest cosine value is going to happen here when it's equal to +1. So both sine and cosine have the same domain, and they also share the same range, which we have written here. Now, it's tradition to use the letter x to denote the variable in the domain of a function. So from here on, oftentimes, I'll use them interchangeably. We'll use theta, but oftentimes you'll see me write y equals sine of x and y equals cosine of x as well to denote our trig functions.